Okay guys, so today we're going to talk about the slope of a tangent line. Now before we talk about a slope of a tangent line, I did notice there's one little typo right here, so this actually is incorrect. This should see p comma x comma f of x. So it's the point x and f of x. I apologize for that. So before we talk about the slope of a tangent line, I want to review what the slope of a secant line is. Okay, so we already talked about at the very beginning of school that the slope of a secant line represents the rate of change, or the average rate of change between the 2 points. So say, for example, I have this point x. It would have the corresponding y value, f of x. And then, say, for example, I don't know, I have this point right here, okay? And I'm going to call this distance between my 2 points h. So if I'm already at x and I need to get to h, my x value would be x plus h. And then my f of x value would just be f of x plus h. Okay? And as we already saw, the slope of this secant line here represents our average rate of change between those 2 points. So we know then that the slope of our secant line is going to equal to, just like all slopes, y2 minus y1 all over x2 minus x1. Okay, and we are going to use the ordered pairs we have from this situation here to figure out the slope. So this first relationship would obviously give us the ordered pair x comma f of x. And this second relationship here would give us the ordered pair x plus h comma f of x plus h. Okay, and we're going to fill those into our slope formula for the slope of our secant line. So y2 would be f of x plus h minus f of x all over x2, so x plus h minus x1, which is just x. Now, if I simplify this a little bit, I'll end up with f of x plus h minus f of x in my numerator, and then my denominator simplifies to just be h. Okay, so that's essentially the slope of our secant line. The difference in our y's divided by our change in our x's. And we already knew that we just changed our, we already know that we just changed our x's by distance of h. Now, that's great for the slope of a secant line, but your notes say the slope of a tangent line, meaning instead of intersecting my graph at 2 points, I'm going to intersect my graph at just 1 point. Okay? So that means then that the distance between my points, this distance h, needs to not be there. So my distance needs to be 0. But if my distance is 0, then I'm dividing by 0. And we are not allowed to divide by 0. But we have a mathematical thing that allows us to get super, super, super close to 0. And in case you forgot what we've been doing in class for the past month, that's called a limit. So we say then that the definition, so for a slope of a tangent line at a point, so the slope of the curve y equals f of x at the point p x comma f of x, so the p is just there because it's representing a point, is the number in which I don't know why I just put an equal sign. Whoa. I don't know what's happening. I don't have an eraser anymore. There it is. I found it, everybody. I know your word. And it won't even let me erase. Oh, Lord. Thank the Lord. Whatever. Okay. Whew. I'm going to black out this equal sign so it's like it's not there. So, is the number, the limit, as our distance between our points was h approaches 0 of our slope formula. Okay, this is a minus sign. So that's all it is. We're going to take the limit between 2 points. So far we've taken the limit of a function, we're going to take the limit between 2 points. So what I'm going to do with you guys right now is we're going to do one example. So I'm going to walk through A and B with you, and then you guys are on your own for C, and then we're going to really quickly look at normals of a line. Shouldn't take that long, probably just about 5 more minutes, so hang in there. Okay, so example 1 says f of t, so for time, we're dealing with a real situation here, is equal to 2t squared minus 1 represents a position function in feet of an object at time t seconds. So in order to do this, I'm going to use the definition of the slope of a tangent line that I have right here, and we're going to plug in, and we're going to figure out exactly what's happening at 2. So to start, we need to figure out what f of x plus h is and f of x is. Okay, or in this case, f of t plus h and f of t. So we already know f of t. That's given to us here. So just to make sure we're on the same page, we know that f of t plus h, if I plug that in, is 2 times t plus h squared minus 1. Right, if I just use my function notation and substitute this in for t squared. And just because I like everything in the same place, I know that f of t is equal to 2t squared minus 1. I just got both those from the formula. So now I'm going to actually use my definition of slope of a tangent line. So when I do that, I'm going to get, and I just realized I did not leave you enough space, so I apologize. I'm going to zoom in for me. I guess we have a lot of space over here. Okay, so when I get there, and when I plug it in, I'm going to get the limit as h is approaching 0 of 2 times t plus h squared minus 1 minus f of x, so that's minus 2t squared minus 1. Make sure you plug that in parentheses, all over h. Okay, now I obviously can't just use substitution right away because then I'm dividing by 0. So just like before, when you divide by 0, that's your hint to do something else. So right now, the something else we're going to do is we're going to expand our numerator and simplify the heck out of it. So when I expand my numerator, I'm going to get the limit as h approaches 0 of 2, and then I'm going to use binomial multiplication, or the box method, to expand that piece of it. So that's going to be t squared plus 2th plus h squared minus 1. And then when I distribute this negative, I'm going to get minus 2t squared plus 1 all over h. Okay, now right away, hopefully you see this negative 1 and that positive 1 cancel, and I'm going to have to distribute this 2 to all of these terms. So then I'm going to get the limit as h approaches 0 of 2t squared plus 4th plus h squared minus 2t squared all over h. Okay, look, things are canceling. Woohoo, that's what we like. So we got to keep going. So now we have the limit as h approaches 0 of 4th plus h squared all over h. Now I still can't divide by 0, but things are a lot more simplified. And I'm going to keep going. So whenever you're dividing by 0, that's your hint to factor, and there's no difference here. So this is going to give me, and I promise we're almost done, the limit as h approaches 0 of h times 4t plus h all over h. Look what cancels. No longer dividing by 0. I just need to substitute in, and I'm going to get 4t plus 0, which is just 4t. Whew, I know that was a lot of work, and I want to point out to you that I kept my limit symbol all the way down because I was always using the limit. I don't have an equal sign here, not until I plugged anything in. Okay, so keep that in mind. Now, I really screwed up with the space on this problem, so I apologize. If I go back to the question, it says find the instantaneous rate of change at t equals 2. Right? It doesn't say, like, you know, wherever the heck you want. That's not a good color. There, that's an ugly color. Okay, right here, t equals 2. That's what we needed. Here I have the instantaneous rate of change as a function of t. I don't need it as a function of t. I need 4t at t equaling 2. So I know then my instantaneous rate of change is 8. Okay, meaning the slope of my tangent line is 8. So part B says we need to write the equation of a tangent line at t equals 2. Well, lucky for us, we just found the slope. And hopefully we all know that we have an x-coordinate and we need to figure out the y-coordinate. But we have a function, right? It was given to us. So f of 2 is going to be 2 times 2 squared minus 1. So what is that? 4 times 2 is 8 minus 1, so that's going to get me to 7. So this is 7. Now, it is perfectly acceptable in this class to leave your equations of a line in point-slope form. You do not need to put them in slope-intercept form. So the equation of this line is y minus 7 is equal to 8 times x minus 2, and that is all we need to do. Okay. Now I'm going to leave C for you to do. Keep in mind, in order to write an equation of a tangent line, you need to find the slope first. So you need to go through this whole process again, or maybe not. See if you can problem solve it to figure out exactly what the slope of our function is at t equals 1. Okay, so pause the video and do that. I'm going to go ahead then and talk about normal lines. And normal lines are a piece of cake. So a normal line, the normal line to a curve at a point is the line perpendicular to the tangent line at that point. So hopefully you know, and if you don't, write this down, that perpendicular lines have negative reciprocal slopes. So for example 2, it says find the normal line of 1 for the example 1a above. So we know that in 1a, our slope was 8. So when we figure out the perpendicular line, we need to take the negative reciprocal of 8. So the slope of our perpendicular line, remember that upside down t means perpendicular, is negative 1/8. And from 1a, we also have that point already, okay? So the point we already have is right here. We already have 2, 7. So we need to use that same point. Do not just pick another point. That point matters. We need to use it. So we have the point 2, 7. And again, point slope form is our best friend. Y minus 7 equals negative 1/8 times x minus 2. If you would like to do y-intercept form, go for it. Or slope-intercept form, not y-intercept, sorry. But this is so much less work. Don't do more work. Okay, that's it for today. Don't forget to do 2C, or sorry, example 1C. Please let me know if you have any questions. I know that some of this limit stuff, can get super, super, super tricky. Okay, I get it. I've taught this class many times. I took this class. It's hard, especially if you're not that great at factoring, and I promise we're going to be working on it a lot more. Okay, let me know if you have any questions.